Okay, today we're going to look at solving quadratic equations with imaginary solutions. So if you haven't talked about or thought about imaginary solutions in a while, what imaginary solutions refers to are solutions to the problem that you wouldn't find in real life. So the imaginary number that we have today I will refer to as I, but it's when you take the square root of -1. And the reason that this is imaginary is because when you do the square root, it's impossible to take the square root of a negative number, because any number that gets multiplied together by itself, so if I did, let's say for instance, -3, if I did -3 squared, I'm going to get a +9, because -3 times -3 gives me 9, and it's a +9 because negative times a negative is a positive. So when I do the reverse of that, there's no way for me to take the square root of something and get back to a negative number, because there can be no negatives that are in there ever. So we're kind of dealing with a number that doesn't really technically exist, but the thing that we're using it for is when we find the roots of these quadratics, if it doesn't cross the x-axis, there's no place where x equals 0, but we get some imaginary roots just because of the way the quadratic function works out. So we'll be writing our answers as if it's a square root of -a, then we'll just put an I on the outside, and I is going to represent -1, and then the square root of a. So if I had down here the square root of -5, I'm going to rewrite that as the square root of -1 times the square root of 5, because -1 times 5 would give me that -5. And all that happens here is that -1 is just going to turn into that I, and the square root of 5, there's nothing that I can take out of that, nothing that pairs up there, so it would just be I square root of 5. Now when I look at number 2 here, if I've got a -25 and taking the square root of that, we're going to think of that as the square root of -1 times the square root of 25. And so again, that -1 is going to turn into just an I, and then we'll have the square root of 25. But in this case, I can break that 25 down a little bit, and we get pretty quickly that 25 would be split up into 5 times 5, or you just know that the square root of 25 is 5. But when I take the 25 and split it up into 5 times 5, that pair goes together and it's able to move outside. So the correct format we write it in is whenever I get a number that's not imaginary that comes outside, it's going to go in front of that I. So I would write that answer as 5I. And so it's a little bit weird thinking about the fact that now we're putting a letter in there as part of an answer, and that letter doesn't actually represent a real number. But this is the format we write it in, and it's a way to represent that solution to this. We'll do the same thing for -45, but let's go ahead and just do a little bit of our splitting up here. So I split this up into a -1 And 45 I could split up into 9 times 5. So if I were to do -1 times 9 times 5, I would get back to that -45. Then 9, of course, I could take the square root of, splits up into 3 and 3. So that gives me a 3 that's going to come onto the outside. And remember that -1, we're going to change to an I. That'll go to the outside. So I would have on the outside of the square root sign 3I. And then I've got that 5 that still stayed inside. It didn't pair up with anything. So I'd have 3I square root of 5. And on the last one, I've got the square root of -180. So splitting that up, I've got a -1 that I'll pull out. Then I could think of this as 18 times 10. So 18 splits up into 9 and 2. And that 10 splits up into 2 and 5. So we've used both of those. That 9 I know will be, I can take the square root of that because it's a 3 times 3. So I've got a 3 that's going to come to the outside and a 2 that's going to come to the outside, as well as that -1 that'll turn into the I. So anything that's circled, I'll multiply those together. 3 times 2, it's going to give me a 6. So I'd have 6I from that -1. And then I've got a 5 that did not get used. That's the only thing that wasn't used. And so that would be 6I in the square root of -5 would be my simplification of that. Okay, we're going to look now at if I've got a quadratic function there that I need to solve, and what happens is this one will not work out this one won't work out by factoring. And if I were to take and graph this, finding my vertex and doing all that, I get a parabola that doesn't cross the x-axis here. So when I'm looking for when it equals 0, well, technically there's nothing that equals 0. So we're going into those imaginary numbers, and what I do with that is I'm going to have to use my quadratic formula. So for my quadratic formula, so remember that in the first space, that 5 we're going to use as a. So a is equal to 5. That second coefficient would be my b value. So b is equal to 6. And then c is going to be that 5. So c is equal to 5. Okay, then my quadratic formula, x equals -b plus or minus b squared minus 4ac over 2a. So let's work that out and simplify it. X equals -b, so -6 plus or minus the square root of b squared, so it'll be 6 squared minus 4 times a, which is 5, and times c, which is 5. And all of that is over 2 times a. So 2 times 5. And as I simplify that, notice pretty quickly that 4 times 5 times 5 is going to end up being definitely bigger than 6 squared. So I'm going to end up with a negative there. So as it simplifies, I have negative 6 plus or minus the square root of 6 times 6 would be 36 minus 5 times 5 is 25. 25 times 4 would give me 100. And last part on the bottom, 2 times the 5 gives me 10. Okay, now I need to do my subtraction here. Let's see, 100 minus 36 would give me, it's like 64. So negative 64. So I have negative 6 plus or minus the square root of negative 64 over 10. Okay, and then just like I did up here with these, I'm going to take the square root of that negative 64, which splits up as, let's see, negative 64. I could split up into negative 1, an 8, and an 8, because 8 times 8 gives me 64. So it's like everything will come to the outside, and just remember that negative 1 is going to turn into an I that we use to represent that imaginary number. So I've got negative 6 plus or minus 8i over 10. And we could simplify that a little bit. All those are even numbers, so the most I could do from here is really just divide everything by 2 to end up with my roots being negative 3 plus or minus 8i over 5. And remember, I'm always tempted to think, well, that's minus 8i, so wouldn't that minus cancel out that I? But just remember that I isn't a negative 1, it's the square root of a negative 1. So over here, when we were doing that, that's the square root of that, the square root of all these parts. So that I is the square root of negative 1, which doesn't technically exist. So we can't cancel anything out. We can't really simplify that any more than that. We just get this negative 3 plus or minus 8i over 5. And what that does is it just gives us a factored form that we can kind of use. So if I were to take this and put it in the factored form using my root form to say the x minus the negative 3 plus 8i over 5 times x minus the negative 3 plus 8i over 5, it would get me back to that original equation there. So that's part of the reason why we use that factoring. Okay, let's look at a couple more examples here. So I've got 3x squared equals 5x minus 3. So on this, I need to take these two and move them over here with that 3x squared. So that would mean subtracting 5x from both sides and adding 3 to both sides. So when I do that, those cancel out, and I end up with 3x squared over here. And again, I'm subtracting that 5x from that side as well. So 3x squared minus 5x plus 3. And that's going to equal 0. Okay, so now I've got values that I can put into that quadratic. So my a value would be 3, negative 5 for b, and positive 3 for c. So we have x equals a negative b, so a negative negative 5 would be positive. So positive 5 plus or minus the square root of b squared. So remember, when we do that, if you're putting it into the calculator, that has to be in parentheses, because anytime I square a negative, it's going to end up as a positive. If you don't put it in parentheses, it will show it to you as negative 25 instead of positive 25, which would not be correct. So minus 4 times a, which is 3, times c, which is also 3, over 2 times a. We'll start to simplify that down. I get 5 plus or minus the square root of 25 minus 4 times 9, which would give me 36, over 6. And I need to do 25 minus 36, which would give me, is that negative 11? Yep. So 5 plus or minus square root of negative 11. And I know 11 is a prime number, so not going to get any more simplified than that. All that's going to happen is I'll be able to pull out that negative 1. So the final answer I have is going to be 5 plus or minus I times the square root of 11 over 6. Okay, and that shows you both of your imaginary roots. Remember, these are imaginary because you've got that I in there. But my first root would be 5 plus I times the square root of 11 over 6. Next one would be 5 minus I times the square root of 11 over 6. But writing it like this satisfies both. Okay, looking at the last one, looking at this one, first want to say, oh, it looks like it could work out as a factor, but doesn't actually end up working that way, because there's nothing that would multiply together to get 16 that adds to get 4. So I'm going to do my quadratic formula again. X equals negative b, which would be a negative 4, plus or minus square root of b, so b squared. So I'm going to go ahead and square that. 4 squared gives me 16, minus 4, and then times 1 times 16. So we'll just say 4 times 16. and then over 2 times a, which is just 1. Then we just need 16 times 4, so that would give me 64. So I've got negative 4 plus or minus the square root of 16 minus 64, all that over 2. And then when I subtract that out, so it could give me -48. So I've got negative 4 plus or minus the square root of negative 48 over 2. And so I can factor some out probably of that negative 48. Let's say got a negative 1 that's going to come out. Got a, I'm going to do 4 times 12. So 4 times 12. And that 12 would split up into 6 times 2. 6 splits up into 3 times 2. And 4, of course, would be 2 times 2. Let's see. Cross out those that got split up. And I've got a pair there. A pair there. And then I've got that negative 1. So I've got a 2 and a 2, which gives me 4. And then that I. So it's like I'm ending up with negative 4 plus or minus 4i. And I've still got a 3 that was left on the inside. All that over 2. So we could just simplify it down a little bit. Divide everything by 2. I'd end up with a negative 2 plus or minus 2i times the square root of 3. And again, that represents both of those roots. That's all we're doing with it today. So as you go through the assignment, you'll be putting it into that quadratic form and then simplifying it just as much as possible.